The bar-shaped object on the right is a neodymium iron boron magnet. Unlike a typical bar magnet, this one has been magnetized perpendicular to the bar axis. So, it has not been magnetized in this direction, but rather magnetized perpendicular to that. On the left is a hollow Teflon cylinder which has a black cylindrical shaped high Tc superconductor fixed at its bottom. When the superconductor is warm, it will just sit on the magnet. What we are going to do is to pour liquid nitrogen into this cylindrical shaped container. So, again, when the superconductor is warm, it will just sit on the bar magnet. So, it is just sitting on the bar magnet and it is warm, and now we pour liquid nitrogen into the container. This will make the superconductor cold. So, from room temperature, it will go down to minus 196 degrees C. As you can see, we put a spacer in between the magnet and the superconductor, and when the superconductor cooled, it is now having a magnet which is floating underneath the superconductor. So, it seems attached to the superconductor with some space in between. As we can see, we can pass a paper through it, and so there is the magnet which is floating underneath the superconductor. The magnet is said to be strongly pinned to the superconductor and stays floating underneath it. This concept can be utilized in constructing a levitating train. The rails here are made of permanent magnets, just like the one we saw in the previous picture. And the superconductor is inside the carriage here. So, in the video showing here, we are going to pour liquid nitrogen into the carriage to make the superconductor cold, that is superconducting. And right now it is placed over the rails with some Teflon spacer in between. Now we wait for the superconductor to cool down. And now we will remove the spacer. We find that the superconductor maintains a floating position. This can be demonstrated by pushing a paper through it, and we see that there is the superconductor which is floating above the magnet. If we push this carriage now, it can move over the rails without any friction. There it goes. So, you have a train which is now levitating over the rails. This has been proposed as a futuristic mode of transport. It can move over the rails continuously without any friction. We note once again that there remains a gap between the superconductor and the rails. We should note that as the liquid nitrogen evaporates, the superconductor becomes warm. That is, it attains a temperature higher than its superconducting transition temperature. When this happens, the superconductor will simply obey gravity and fall on the rails. If we could discover a new superconducting material which has a very high Tc, then such an elaborate cooling arrangement will not be necessary. In that case, the cost of constructing such a transport system will also not be prohibitive.